Okay, good day. This is Honors Algebra 2. I am Mr. McCully, and this is section 4.5, completing the square. Let's get right to it. Today we are going to use the principle of square roots to solve quadratic equations by either A, extracting square roots, or B, completing the square. So what is that principle of square roots? That principle of square roots says this: if you know an expression is x squared equal to some constant k, then you can say that x is equal to either the positive square root of k, or you can say that x is equal to the negative square root of k. And that makes sense because if we were to square a positive value, we would get a positive value. And if we were to square a negative value, we would still get a positive value. So whenever you take the square root of something in solving an equation, you have to consider both the positive and the negative. It also works when we're talking about a binomial expression like this. So if I have an x minus a and I take the square root of both sides, I have to consider the positive and the negative. So the solution to this would be to first take the square root of both sides and then add this negative a to both sides, which would give us a plus square root of k or a minus square root of k. If you recall from our last section of factoring, there were two perfect square binomials. We're going to use these to help us solve these equations. Now, first example. Given the perfect square quadratic equation, solve for x. So in this particular situation, they are saying that this is already a perfect square. This expression that I'm highlighting right here is already a perfect square binomial. It already fits into one of these two expressions. This fits into the a squared plus 2ab plus b squared form. And its result is going to be a plus b quantity squared. Now all we have to do is determine what a and b are. If a squared is equal to x squared, then a is just going to be x. If b squared is equal to 36, then just b will equal 6. And we feel good about that situation because here in the middle, this 2ab, if I go 2 times x times 6 and reorder that, I'll get 12x. So now I can rewrite this expression as x plus 6, quantity squared equaling to 16. And now I can go back and use this principle of square roots and this expression right here and say that the way we're going to solve this is we're going to take the square root of both sides. And so I'll go x plus 6 equals plus or minus the square root of 16. And then I will subtract 6 from both sides. And I'll have x equals negative 6 plus or minus the square root of 16. Now I know what the square root of 16 is. From our last lesson, we know that the square root of 16 is just 4. So I have negative 6 plus or minus 4. Now since these are like terms, I can combine them. Negative 6 plus 4 is negative 2, and negative 6 minus 4 is negative 10. And so those are my two solutions to this problem. This expression right here is a little bit different, but it still has, and again, we know because it tells you that it's a perfect square, it has this second form right here. So we can say that a squared minus 2ab plus b squared is going to equal to a minus b quantity squared. In this particular instance, similar to the one before it, the a squared value is the x squared value, so we know that a is equal to x. The b squared value is a little bit more challenging. It's 49 over 4. It can be rewritten as b, well, 49 and 4 are both perfect squares, so if I take the square root, I'll get 7 over 2. And again, I feel confident in that because if I go 2 times x times 7 over 2, I will get 7x, which is this expression right there. So I feel confident that this expression right here is going to be x minus 7 over 2 squared is equal to 9. So just like in the last one, I can take the square root of both sides. That'll give me x minus 7 over 2 equals plus or minus the square root of 9. I can add 7 over 2 to both sides. I'll get x equals 7 over 2 plus or minus. Now I'm going to just take the square root of 9 and say that it is 3. Now, I can still combine these because they're still like terms even though I have a half. So now I need to change my 3 into halves so that I can have common denominators. So I'll have 7 over 2 plus, there are 6 halves in 3. So now I can go 7 plus 6 is 13 over 2, and 7 minus 6 is 1 over 2. So we have that. Now let's talk about completing the square. Whenever you see x to the second power, we say that it is x squared. Now there is a reason for that, and it's geometric in nature. If I take a segment and I mark off the first length of that segment and I call it x, and then I take 3 more lengths of that segment, let's move this down so that it fits. There we go. And I call each of those lengths 1 unit long. Then the length of this segment is x plus 3. If I make an additional segment along that line and I divide it into 3 equal segments, 1x and then 1, 2, 3, 3 units, it is also x plus 3 units long. If I complete the square and draw in a square, and let's fix that, then this thing has the area of x plus 3 quantity squared. Why? Because the area is length times width. If I connect my segments here like this, then the area is not only the x plus 3 quantity squared, but it is also the sum of the areas of all of these rectangles. Now this rectangle right here is just x squared, and then this rectangle will be x times 1, which will be x. Now all of the remaining 5 long rectangles will also have area x in them. And this box right here is a 1 by 1 box, so its area is 1. All of them are 1. The area is not only the length times the width, but it is also the sum of all of the pieces. And those pieces add up. I have my x squared. I have 1, 2, 3, 4, 5, 6 x's. So I have 6x. And I also have 1, 2, 3, 4, 5, 6, 7, 8, 9 units plus 9. This is a perfect square trinomial. And so what we're going to try and do here is we are going to, in these next examples, what we're going to try and do is find a value of c that makes this into one of these perfect square trinomials. I'm going to take this b value, I'm going to divide it into 2 so I can make these rectangles along the sides, and whatever this length is squared becomes the units that we're looking for. So again, the way we're going to solve this is we're going to take the b value, we're going to say c is equal to b divided by 2 squared. So we'll go c equals 10 divided by 2 squared, which is equal to 5 squared, which is equal to 25. So now that c is equal to 25, I can rewrite the trinomial x squared plus 10x plus 25 equal to a perfect square binomial. And that perfect square binomial is just going to be this b over 2. And we'll go x plus whatever the b over 2 was, so 5 squared, and that is going to be our answer. It also works for negative values. So if I say that my b is equal to -6, then c will be b over 2 quantity squared, and we'll go -6 over 2 quantity squared equal to -3, and then -3 times -3 is 9, so my c is 9. My perfect square trinomial is x squared minus 6x plus 9, and that is going to equal to the perfect square binomial of x minus 3. And that is my final answer for that. Completing the square. If we're going to solve equations using completing the square, we're going to start with ax squared plus bx plus c equal to 0. I'll solve for x. And so here's what we're going to do. And these are the steps for all of them. We're going to move the constant to the right-hand side, so that we'll subtract c from both sides. Then we'll divide both sides by a. If a is equal to 1, then we're just going to skip that step. Once we've divided by a, we're going to add b over 2 squared to both sides of the equation. And then we're going to complete the square, which is essentially what we did right here. We're going to add a c value to both sides so that we have a perfect square binomial. And then we're going to solve for x using the principle of square roots, which we've already done. So I have two examples, one where a is 1 and one where a is not 1. And this one is, again, an easy one. So we're going to follow the steps. The steps say, first, move the constant to the right side. So my constant is my 8. So here I'm going to subtract 8, and then I'll have x squared plus 6x equals to -8. And so now I need to complete the square. So I'm going to add that b over 2 squared to both sides. All right. So in this particular case, b over 2 is equal to 6 over 2, which is 3. And so I am going to add 3 squared to both sides. And here we're going to complete the square. So this expression now is that perfect square binomial like we did in just the last section. It's x plus 3 quantity squared, and this side is going to equal, well, I get -8 plus 9 is 1. So now I'm going to take the square root of both sides. And that'll give me x plus 3 equals plus or minus the square root of 1. And again, remember, anytime you take the square root of both sides, you have to add plus or minus. And so now I'm going to subtract 3, and I'll have x equals -3 plus or minus, well, the square root of 1 is just 1. And so x is going to equal -3 plus 1 is -2, -3 minus 1 is -4, and we are finished. Next, we're going to solve the quadratic equation by completing the square. So the first thing that we're going to do in this particular instance is we're going to move the constant. And in this case, we're going to do that by adding 5. And so we'll have 2x squared minus 7x equals to 5. And now, in this particular case, a is equal to 2. So, divide both sides by 2. And we're going to get some fractions, and I know that's okay. So if I divide both sides by 2, I'll have x squared minus 7 over 2x equals 5 over 2. And so in this case, now we have to add b over 2 quantity squared to both sides. All right, so I have my b is 7 over 2 already. So if I take 7 halves and I divide by 2, I'm going to end up with, and I'll write this down, so 7 over 2 divided by 2 is equal to 7 over 4. All right, when you divide 7 halves into halves, you get 7/4. So here I'm going to add negative, and I should put negative for all of these. Negative 7 over 4 squared to both sides. All right, now this particular perfect square binomial becomes x minus 7 over 4 squared. And so now I have to add my terms here. So 7 over 4 squared. 7 squared is 49, and 4 squared is 16. And since I'm squaring it, it becomes positive. So I need to figure out a common denominator. 2 times 8 is 16, so I've got times 8. 5 times 8 is 40, and so 40 plus 49 is 89 over 16, and I'll have x minus 7 over 4 squared. I'll take the square root of both sides. I'll have x minus 7 over 4 equals plus or minus the square root of 89 over 16. Now I want to add 7 over 4 to both sides. That'll give me x equals 7 over 4 plus or minus, well, I can separate these two things into the square root of 89 over the square root of 16. Since 89 is prime, the square root of 89 cannot be reduced. But the square root of 16 can be reduced. So we can reduce this down to 7 over 4 plus or minus the square root of 89 all over 4. Now this is good like this, or since we have common denominators, we can rewrite it as x equal to 7 plus or minus square root of 89 all over 4. Both of those two forms are correct. Well, that's all I got for today, folks. So, the Mandalorian fun fact of the day, Werner Herzog plays the client in his first season of The Mandalorian. He is an accomplished director, documentarian, and actor in his own right, directing the 1979 classic Nosferatu and the Vampire, and having roles in a lot of modern pop culture like The Simpsons, Rick and Morty, and Parks and Recreation. That's all I got for today, folks. Have a good day.